Might Proxima b at some point be another Earth-like planet? These are theories everybody continues to make. The quest for an elective livable planet and extraterrestrial life on different planets is something people are entranced with. There have been different hypotheses, and the reality that there have been signals coming from Proxima b causes individuals to accept there is more to it. In spite of these multitude of signs, we still can't seem to decide whether these are messages from the planet or simply repeats of our own. Researcher flags frequently result in reverberations. In finding out whether these signs are really from Proxima b, researchers desire to determine if extraterrestrial life exists. Recently, the James Webb telescope identified fake lights on Proxima b. If you're keen on finding out about different planets and our progress in tracking down alternate life, subscribe to our channel. We make content about space and discuss advancements in science. If you like this content, comment below and share this video with your friends. Now, let's go back into our video. Proxima Centauri, around 4.2 light-years from our solar system, is a weak, small star defined as a G-type. This star is known as Proxima Centauri. It was named Alpha Centauri in 1835 by Johann Bessel, derived from the stars rising around early afternoon when a few celestial bodies, like the Moon and the Sun, were in a straight line. Proxima Centauri is also known as Alpha Centauri A or Alpha Centauri. It is a solitary star system with 4 primary stars in a line. Proxima Centauri is at the center of this system. Separated from the 4 stars, there are 2 weak, diminutive companions, Alpha Centauri b and Alpha Centauri c, which make up the majority of the mass but are too weak to be seen by the naked eye. The system is found 23 light-years from the line of the famous Ploughed asterism in the constellation Centaurus. Despite the fact that Proxima b is a rocky planet, there is still hope that it could have extraterrestrial life. The search for some other life out there has brought researchers to Proxima b. They believe the similarities to Earth's size and the distance it is from its small star make it a suitable candidate for planets that can accommodate life. While all of these are theories, there's hope that there may be some truth to them. There is much to find out about Proxima b and the orbit it takes, so stay tuned and keep watching. You can also check out some of our other content related to extraterrestrials. Do you truly believe there's another life out there? Leave a comment down below. What intrigues most people about Proxima b is its similarity to Earth. Studies show that Proxima b is an exoplanet that orbits an M-type star. Its mass is considered to be 1.27 times that of Earth. Furthermore, Proxima b takes 11.5 days to complete one orbit of its star. It was found in 2016, and many researchers are studying it. Although Proxima b looks like Earth, specific features make it less hospitable. For one, the planet is too close to its star and, as such, continues to get extreme ultraviolet radiation from the star. It is estimated to be many times more intense than the radiation we receive from the Sun. This radiation is strong enough that it strips away even the lightest hydrogen particles, and over time, it does the same to oxygen and nitrogen. While many people could argue that Proxima b should be habitable because it is at a similar distance from its star as Earth is from the Sun, there is more to it than meets the eye. Distance doesn't account for whether there is water on the planet. There is also no proof of an atmosphere that would be conducive to life. Earth's atmosphere makes it livable, while Mars's does not. The right atmosphere makes it possible for environmental regulation and a water-friendly surface. It also protects living creatures from dangerous space weather. If you're with us up until this point and haven't subscribed yet, take a moment to hit the subscribe button. It makes it easy for us to keep making content like this that you'll love. Now, let's see why people think the James Webb telescope will help us figure out whether or not there is life on Proxima b. The James Webb telescope was launched in 2018 after being delayed since 2011. Many changes had to be made to ensure it provided accurate pictures during its creation. Webb explained that if a planet like Proxima b could absorb light from its star, it could also emit it as infrared light. The James Webb telescope was specifically designed to observe infrared light. It can take pictures of this light on the surface of a planet and search for patterns that could confirm if the planet has water or an atmosphere. One reason space telescopes are preferred over ground-based ones is that by being above the atmosphere, they don't need to look through the moving air to see deep into space. As a result, They get a better view of what happens outside the local solar system than most ground telescopes can achieve. Another advantage is that weather changes on Earth don't affect them, and astronomers can be sure they're getting a clear reading. The main drawback to having a space telescope is that repairing it is costly if something goes wrong. There have been situations where a minor flaw in a space telescope required a full mission into space to fix it. Such expenses make observing planets like Proxima b difficult with the James Webb Telescope. Since it has been launched over 1.5 million kilometers away, farther than any human has ever traveled, salvage missions are impossible. The James Webb Telescope comes with a larger mirror, allowing us to see all the way back to the start of the universe, almost 13.7 billion years ago. The further away an object is, the further in time we get to see it. The reason for this is that light takes time to travel. The ability of the James Webb Space Telescope to see the universe in a longer wavelength, in infrared light, means we get to see more distant worlds in our universe with more clarity than was previously possible. Thus, observing planets like Proxima b has become easier, and it has pushed the light out of the visible spectrum and into the infrared. Tabor and Curve have a scale for artificial light, which shows how the sun illuminates and reflects the day side of the planet. At 0% on the scale, one would expect the planet's night side to be completely dark with no light. At 100%, it means the planet's night side is just as bright as the day side. There has been a speculative human civilization on Proxima b using this type of light, and most researchers believe it is like the good old days on Earth. Studies show that if the evening side of Proxima b reaches an illumination of 5% of the average day side, then the James Webb Telescope could detect the artificial light by 85%. If the illumination reached 9%, the telescope would detect up to 95%. Although 5% light sounds like a small number, we're talking about light from a star like Proxima Centauri compared to our sun. Proxima Centauri's light is much dimmer, yet we still have a lot of light from our star. This essentially means that even at 0.1% of brightness, we are still reflected in the celestial light. In other words, if Proxima b has any human civilization that is using artificial lighting like Earth, the James Webb Telescope might not detect it. The stars would need to be around 500 to 1,000 times brighter. This scenario is unlikely since Proxima b orbits so close to its host star. There is a chance that Proxima b may be tidally locked, meaning one side of the planet constantly faces the star while the other remains in perpetual night. Living on a tidally locked planet would require focusing on illuminating the night side and using extremely bright orbital mirrors to reflect sunlight from the day side to the night side. All of these are hypotheses made by Tabor and Curve, and there is yet to be proof to show that they are true. The planet's illumination should be visible from space and is known as airglow. Many people wonder why the world is surrounded by bright shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. Airglow occurs when particles and molecules in the upper atmosphere emit light to release excess energy. On Earth, airglow can happen when atoms and molecules are ionized by sunlight and capture free electrons. The glow appears similar to an aurora, except that auroras are driven by high-energy particles from the solar wind. The airglow is driven daily by solar radiation. Since the James Webb Telescope's launch, researchers have been questioning whether it is sufficient to observe distant planets in far-off universes. Despite being the farthest satellite telescope ever launched, it still provides very limited information needed to find planets with life in other universes. As such, there have been discussions about creating larger and better telescopes. These efforts are often expensive and involve a lot of trial and error. The James Webb Space Telescope's launch was 5 years late due to these issues. Therefore, it is challenging for most researchers to develop better technologies that can be launched further into space. Despite this, the James Webb Space Telescope's results are promising. Soon, we could know whether there is life on Proxima b and other planets. While work is still being done on additional telescopes, the anticipated completion and launch of the HABEX, Habitable Exoplanet Observatory, will revolutionize space exploration. The estimated completion time for HABEX is 2035, with a launch soon after. HABEX will be sensitive to all planets in the universe. Although its main goal is to search for Earth-like planets, its advanced technology will enable it to measure the spectra of most planets and determine whether they are habitable. HabEx is also expected to have a wide range of astronomy abilities, allowing it to study the earliest potential times in the universe's history, gather data, and understand the life cycles and deaths of massive stars, as well as the elements that support life as we know it. Although HabEx is still in development, the technology used to create it will allow it to study Earth-like planets with such exceptional clarity that images of these planets will be incredibly clear. HabEx will be sensitive to ultraviolet, infrared, and optical wavelengths. The concept behind HabEx is very compelling and will change space exploration as we know it. If it can be pulled off, space exploration will undoubtedly change. People can look forward to more data on extraterrestrial life on other planets. It will also provide a better picture of Earth as it looks back at years before the formation of the planet and the changes that occurred with our atmosphere. Lucy's concept is a smaller version of a telescope, but it builds on our experience with the James Webb Space Telescope. It has ultraviolet capabilities and is considered the next observatory telescope to be used by most astronomers. Astronomers anticipate launching Lucy alongside HabEx. The large UV optical Earth observer will significantly improve space exploration. Studies done with Lucy show that it will be able to understand what makes Earth stand out from the rest. A few observations have been made of 28 Earth-like planets, and the results have been promising. With such telescopes in development, insights into planets like Proxima b can become clearer. Despite the incredible progress made by the James Webb Space Telescope in finding new insights into Proxima b, there is still much to be improved in the visibility of distant planets and the ability to study their atmospheres. Ultimately, the hope is that these advancements will help answer whether extraterrestrial life exists, while providing a deeper understanding of the planet's history and the changes that have occurred over time. Do you ever wonder what would happen if we found extraterrestrial life? Fear not, we have videos on our channel that discuss this and much more. Subscribe to our channel and hit the notification button to be notified whenever we post new content. Is there life beyond planet Earth? The discussion about life on other planets has been happening for quite some time now. Most people believe we are not alone in the universe. There have been speculations and claims that have been discussed for years. Whether we get to know if we have life on other planets or not depends entirely on the kind of research we carry out. For this reason, scientists are working to ensure that we have more space telescopes orbiting Earth and other planets. However, they need to be more powerful and look beyond infrared light to give us better answers about other planetary life. For now, we watch with bated breath as we hope to see if our sibling planet, Proxima b, has any life on it. If you love content like this and want to learn more about the James Webb Space Telescope and Proxima b, please subscribe to our channel. We post videos regularly, providing telescope reviews and insights into Earth-like features on other planets as we search for life outside our world. Like this video and leave a comment down below if you believe we're not alone in this universe. The search for extraterrestrial life continues. One of the fascinating aspects is the possibility of finding biosignatures that could reveal the presence of life on exoplanets like Proxima b. Beyond identifying artificial lights, scientists are also exploring other potential signs of life, such as atmospheric composition and chemical signatures. For example, the presence of specific gases like methane or oxygen, in relation to their balance with other atmospheric elements, could suggest biological activity. Another promising strategy involves studying the planet's surface conditions through remote sensing techniques. Instruments designed to analyze reflected light from a planet's surface can provide valuable information about its topography and atmosphere. By examining these details, scientists can infer whether the planet could have liquid water or other fundamental components necessary for life. Moreover, there is growing interest in the idea of profile signatures, gases that could indicate life. For instance, an imbalance between gases like carbon dioxide and oxygen could imply biological processes. Research into these markers is ongoing, with the hope that future telescopes will be able to detect these subtle yet crucial signs from distant worlds. Additionally, upcoming space missions and technological advancements are expected to enhance our ability to identify and study exoplanets. For example, the development of next-generation spectrographs and other advanced observational techniques will improve our capacity to analyze the atmospheres and surfaces of these distant worlds.